Hello and welcome to this R tutorial. So we already built two regression models. It was the simple linear regression and the multiple linear regression. And these two models were linear models. And now we are going to the next level because we will start to build nonlinear regression models. So that means that for data sets where there will not be a linear relationship between the independent variables and the dependent variable, these nonlinear regression models will be very useful. And speaking of problems with nonlinear relationships, this is the kind of problems that we will have to deal with in the future sections. So in the future sections, we will build nonlinear regression models to solve nonlinear problems. And today, in this tutorial, we will start with polynomial regression. So as usual, let's prepare the workspace by setting the right folder as working directory. So right now I'm going to my machine learning AZ folder, part 2 regression, then section polynomial regression, and here is the right folder. Make sure that you have the position salary CSV file, and you can click on this more button here, and then set as working directory. And now let's start with the usual first step of making a machine learning model. So this first step is of course the data preprocessing step. So to be efficient, I'm going to go to my data preprocessing template that we made in part 1. I'm going to select everything in that template, copy, and paste it in my polynomial regression model. This way. Okay, and now we just need to change a few things. So the first thing we need to change is the name of the data set. So it's not data here. Data was the name of the data set in the preprocessing part. But now in this regression part, the name of the dataset is position underscore salaries. So here we'll write position underscore salaries. And now let's select this line and execute to have a look at our dataset. Okay, and now let's see what will be our machine learning mission. So we are a human resource team working for a big company, and we are about to hire a new employee in this company. So this new employee seems to be great, a good fit for the job, and we are about to make an offer to this potential new employee. And now it's time to negotiate on what is going to be the future salary of this new employee in the company. And so at the beginning of the negotiation, this new employee is telling that he's had 20 plus years of experience and eventually earned 160K annual salary in its previous company. So this employee is asking for at least more than 160K. However, there is someone in the HR team that is kind of a control freak and always fantasized about being a detective, so suddenly decides to call the previous employer to check that info. That info about the previous 160K annual salary of this future potential new employee. But unfortunately, all the info that this person manages to get are these info here. This simple table of salaries for these 10 different positions in the previous company. So this HR member of the team runs a simple analysis on Excel or Google Sheet and actually observes that there is a nonlinear relationship between these position levels and their associated salaries. However, and moreover, this HR guy could get another very relevant info. This other relevant info is that this new employee that is about to be hired has been a region manager for 2 years now in the previous company, and that usually it takes on average 4 years to jump from being a region manager to a partner. So this new employee about to be hired was kind of halfway between level 6 and level 7, and therefore we can say he was level 6.5. So now this HR guy is getting all excited because he's telling to the team that he can build a bluffing detector using regression models to predict if this new employee is bluffing about its salary. So at the beginning the team finds it a little weird, but is kind of curious to see what's going to happen. So here is the mission. This new employee that is about to be hired is telling that its annual salary was 160K in the previous company. Let's use polynomial regression to build a bluffing detector to predict if it's truth or bluff. Alright, and now that we get the problem, let's see if we need all the data set to train our machine learning model, which by the way is going to be the polynomial regression model. remember, the machine is the polynomial regression model itself, and learning is related to the fact that this polynomial regression machine learning model will learn the correlations between the levels here and the salaries to predict any new salary of new levels that are not in this table here. For example, we want to predict the salary of level 6.5. Well, thanks to what our machine learning polynomial regression model learned on this info here, it will be able to predict the salary of level 6.5. Okay, so we noticed that in this data set, this position column is strictly equivalent to this level column. You know, it's like we already encoded this position column, by transforming this variable into numerical variables, and therefore we will not include this position column in the data set where we will train our polynomial regression model, and we will only use these two columns, level and salary, so that the independent variable column will be this level column, and the dependent variable will be the salary column. So let's go back to our polynomial regression model, and here let's select these two columns we are only interested in. So to do this, we will reset the data set. So I'm taking my data set here, and again I'm taking my data set, then brackets, and in this brackets here we will input the indexes of the columns we want to keep to train our machine learning model. So let's see what these indexes are. Okay, so we have three columns. Indexes in R start at 1. So this column has index 1, this column has index 2, and this column has index 3. So since we want to keep these last two columns, then we want to keep the indexes 2 and 3. Okay, so let's input that. To input this, we can simply input to column 3. Let's check it out. Let's select this line and execute. And as you can see now, our data set, if we look at it, only has these two columns, level and salary. So as a reminder, level is the independent variable and salary is the dependent variable. So we will use the correlations between the levels and the salaries to train our nonlinear machine learning polynomial regression model to predict some new salaries, such as the salary associated to a 6.5 position level. Okay, so let's go back to the polynomial regression model. Our data set is well imported now. It's well prepared. We have everything we need. And now let's move on to the next step. So the next step is to split the data set into the training set and the test set. And actually this time, and only this time, we will not do that. And the reason is that we only have 10 observations here. So this is a very small data set. And by the way, I chose this data set because we're still shaping our intuition of machine learning. We're still learning the basics of machine learning. And therefore, I choose this simple data set because we have 2 dimensions here. So we will be able to plot the form of the polynomial regression model itself, as well as the future nonlinear regression models. Okay, so let's go back to our model. And as I just said, we won't need to split the data set into the training set and the test set. So what I'm going to do now is I'm going to put all this section in comments. So let's do this. Press Command or Control plus Shift plus C, and that puts all your selected lines in comments. So no training set and no test set will be created. Okay, and the last step now is feature scaling. And the good news is that we won't need feature scaling either. And the reason is simple. It's that because a polynomial regression model is actually a multiple linear regression model with polynomial terms. You know, instead of having different features, like features that represent something very different, we are taking a first feature, which is actually the position levels from 1 to 10. And as the other independent variables that will be in our multiple linear regression model, we will take the squares and other exponents of these levels here. Okay, so actually that's done. That was actually very simple. No need for training set or test set, no need for feature scaling, just some little changes in the data set here with the indexes, and we're all fine. We're ready to build our first nonlinear regression model, that is the polynomial regression model, and that's what we will be doing in the next tutorial. So I look forward to creating this bluffing detector with you, and until then,